Here we have OpenStax Chapter 4, number 40. I'm going to start by kind of drawing a picture just a little bit to locate where my initial event and my final event are based on these coordinates. Here I just have my y coordinate, or my y axis and my x axis, and my ball is going to be shot at this initial position at x equals 0 and y equals 1.8. And the basket's going to be over here at x equals 6.1 and y equals 3 meters. So this is just how I set up my coordinate system. You can put your origin wherever you want, but the point is that the horizontal distance between here and here has to be 6.1 meters, and the vertical distance between here and here has to be 1.2 meters based on the information I've been given. So it's going to be shot from that initial height, and I also know that it's shot at an angle of 60 degrees. So this vector is going to be pointing upwards, and the angle with the horizontal is going to be 60 degrees. So we want to know what's the initial speed if it makes it into that basket. So let's get going. So in the x direction, what do I know about the x direction from my initial to my final? I know that my x displacement is going to be 6.1 meters. I know that the acceleration in the x direction is 0 because there's no forces on us there. I'm not sure what else I know, so I'm going to go look at what I know about the y direction. In the y direction, I know that my vertical displacement is 1.2 meters, and I know that my acceleration is negative 9.8 meters per second squared. I still need some more variables before I can write equations, right? I always need to know which 4 variables to have in my equation. Right now I only have 2 per direction. So I'm also going to include delta t because that's a variable that's the same in both the x direction and the y direction. And the other thing that I can kind of think about is what's happening with that initial velocity. Okay, let me come over here, and I'm going to say that the ball is launched with some initial velocity. That's a vector because it has a magnitude, the initial speed, and it has a direction. This is that launch angle. Well, if I write my velocity in terms of my magnitude and my direction, I can also figure out the x component of my initial velocity. I can figure that out by taking my magnitude times cosine of my angle. So cosine of 60 is just 0.5. And v initial, that's the initial speed. I don't know what that is, but that's what they're asking me about. What is that initial speed? What is v initial? What is the magnitude of my initial velocity? I can figure out the y component by writing the magnitude times sine of 60. And sine of 60 is 0.866 times v initial. And again, v initial is that unknown initial speed. So let's consider v initial x as a variable I know in the x direction, and v initial y as a variable in the y direction. So looking at this, I don't know v initial and I don't know delta t. That's okay because I'm allowed to have 2 unknown variables in this equation as long as I have a second equation with the same 2 unknown variables, and I will have that when I write my equation for the y direction. So let's choose the equation that involves these 4 variables, and we'll write it for the x direction. So there's that equation. Here I've plugged in the values. Instead of v initial x, I put in 0.5 times v initial, where v initial is that initial speed. And then I've just simplified here. So again, I have 2 unknown variables. For every unknown variable that you have, you need to have the same number of equations. So here's 2 unknown variables, but only 1 equation. To solve for 2 unknown variables, I need 2 equations, and I'm going to get the second one by writing an equation for the y direction. So here's my equation that involves these 4 variables. Here I've plugged in all the values, and instead of v initial in the y direction, I plugged in 0.866 times v initial. That's the initial speed. Here I've just simplified. Okay, so now I have 2 equations with the same 2 unknown variables, so I should be confident that I can solve this. The way that I'm going to solve it, I'm going to focus on this equation, and I'm going to solve for v initial. So I just solved for v initial in terms of delta t, and now I can plug this expression in here for v initial, and that's what I've done here. And then I'll have one equation just in terms of delta t, and I can solve for delta t, and I get delta t equals 1.38 seconds. So I know that going from here to here takes 1.38 seconds. Now I can plug that value back into my expression for v initial, and I find that that initial speed that the ball was launched with was 8.84 meters per second.